In lesson 3.1, we're going to be exploring what makes something a function versus not a function. So we're going to start by looking at this exploration activity number 1. And if you want to give yourself a chance to answer these questions first, pause this video and try some things out before you hear the actual answer. So we're going to talk about the different ways that we can describe a function. It might be through an equation, through an input-output table, by using words, by looking at a graph, or looking at a set of ordered pairs. So A asks us to explain why the graph shown represents a function. Okay, well, the definition of a function, which you should have already done in the previous activity on the previous page in this lesson, was to define some words. Okay, a function is defined as a relation that pairs each input with exactly one output. Okay, the x's are our inputs. So these are the inputs, and then the y's are the outputs. So on this graph right here, when we input 0, we have the output of 8. When we input 1, we have an output 6. When we input 2, we get 4. 3, we get 2. And 4, we get 0. So this represents a function because it passes something that we'll talk a little bit more in a minute about, which is a vertical line test. At no point can I have an input. For example, when I put an input of 0, the only thing I get out is 8. I don't get a 6, I don't get a 4. Now when I move over to 1, I get a 6. I don't get any other output. So that is why the graph represents a function. So there's, for each input, there is exactly one output. So in B, when it wants us to describe the function in two other ways, I kind of already did that. This is one way to describe the function. We used ordered pairs. You could also create an input-output table, like an XY table, where we would have the 0, 8, 1, 6, 2, 4, and so on. So that's two other ways to show and describe this function. In exploration 2, we're going to identify a function, this time not from a graph, but from a table. And so the thing that you really want to look for when you're looking at a table would be the inputs or x's. They must all be different. If they're not all different, we have to look at something else. So let's look at these inputs. 0, 1, 2, 3, and 4. They're all different. So this is a function. Now in B, because the inputs 8, 8, and so on, they're all the same. Well, if they're all the same, we should have the same outputs for each one. We don't have that. We have different outputs for each one, so this is not a function. Now let's look at an input-output mapping diagram to see how we can tell if that shows a function or not. So in C, it gives us 3 different inputs, 1, 2, and 3. The 1 goes to the 8. That's great, because that means there's only one output for 1. The 2 goes to the 9, also great. There's one output for the 2. The 3, however, goes to a 10 and an 11, and that breaks our rules. So this one cannot be a function because you cannot have two different outputs for one input. In D, this one gives us a graph. So what we need to look for in a graph is we need to look and see if at any point more than one dot will be touched by a vertical line. And so I see several places where the vertical line test would pass. For example, here it would pass. Here it would pass. However, right here does not pass. Nor does it pass at this point. So it fails the vertical line test, so it's not a function. Now, how do we look at just list of ordered pairs? How can we tell if those lists of ordered pairs are functions or not? Well, in E, we're going to look at just the very first value in the ordered pair. So I have -2, -1, and I'm looking for something to repeat. If none of those x values repeat, it's going to be a function. So -2, -1, 0, 1, 2. Nothing repeated. As long as no x values repeat, you're going to have a function. In F, let's look and see if we see anything repeat. -2, -1, -1. Okay, well those repeat, so this is not a function as long as they have different numbers and that are for their outputs, and that is the case here. Because we have a -1 with an output of 0 and a -1 with an output of 1, so not a function. Okay, let's look at G, which is in this case really just an example, not with just numbers, not with just a graph, but each radio frequency X in a listening area has exactly one radio station Y. Each X has exactly one Y. This is a function because that's basically the definition of a function. For each input, there's exactly one output. And then H, the same television station X can be found on more than one channel Y. Well, this is an example of something that would not be a function, because if my output can be the same, there's more than one Y, they can't all have the same X, so not a function. So I gives us a different way of looking at this with an equation, okay? So in I, the equation is X equals 2. Okay, so if I have an input, because this is an X, our X's are our inputs, an input of 2. Now, there is no Y defined here. We don't have a Y here at all. This would actually be the graph of a vertical line. Any Y for the input value of X equals 2. So if it's a vertical line, at that particular vertical line, it's going to fail the vertical line test every time. So if it's going to be X equals a number, it is not a function. Now, if you see Y equals a number, that one would be a function, because the Y values can all be the same, and the Y value would be a horizontal line. Okay, so the Y values, the outputs are all the same. That can happen. We can have a repeating output, just not a repeating input. And then the very last one, Y equals 2x plus 3. This is going to be a function. Anytime you see the equation set up as Y equals something X plus a number, you could graph this in your graphing calculator. You could see that it's a line that's not a vertical line. It's going to pass the vertical line test, so this is a function. So just to review, you have your two examples of the vertical line test, where it is a function and where it's not a function. We've already discussed that in some of our examples. And then you also have this example here, the next one is showing domain and range, and that's the next thing that we're going to get into, is defining what domain and range are of a function. So you should have done your vocabulary already, and you would have discovered that domain refers to the input values, which are x values. The range refers to the outputs, or the y values. And this is important when it comes to function, because for each input there's only one output. So we're looking at numbers that are contained in the domain and contained in the range. So before we work with some examples of domain and range, let's look at our extra practice questions and decide whether something is a function or not a function. We're going to use F to identify function, and NF to identify not a function. So in number 1, we look at our input values, and I see where the inputs are repeating in one place, but the outputs are different. So this is not a function. In 2, when we look at each of our x values, 0, 1, 2, and 3, none of those repeat, so this will be a function, regardless of what the y values are. Number 3 fails the vertical line test. Right there, it's going to touch both of those points. So that's not a function. But number 4, no matter where we cross it, no matter where, you're only going to touch one part of that line, so that is a function. In 5 and 6, again on 5 we can use the vertical line test, and that one's going to work out well for us if we're going to decide whether it's a function or not. So this one would be a function. Now when there is a function, we can identify the domain and range of that function. So we're going to use D for domain and R for range. And when there are discrete ordered pairs, sometimes it's best to just look at them as ordered pairs, or maybe make a table of the values. And so on number 5, I could make me an XY table. So 0, 1, 2, 3, 4, 5. Would be our x values. Now when x is 0, y is 4. When x is 1, y is 4. Again, it's okay that the y's are repeating. 2, 4. 3, 3. 4, 3. And 5, 3. So in this example, the domain is 0, 1, 2, 3, 4, and 5. And kind of note that you do have to write each one of those out when you are listing out the domain. On the range, however, I only need to list 3 and 4. I don't need to repeat the 3 even though it's there 3 times. Now on 6 is very different because it does not have discrete points. It has a starting point and a stopping point, and it has things in between. So in this case, when I'm referring to the domain, it's going to be x, and then the range is going to be y, and we're going to have to use some kind of inequality symbol. Okay, so on the x-axis, it starts here, and it ends here. So it's going from -3 to a +3. And so the way we would want to write that is -3 is less than or equal to, it's a solid circle, so we have to use less than or equal to, x, which is less than or equal to 3. And that's how we would define the range when it's not discrete. We call this one continuous. And then for the range, we'll do that one in blue. The lowest point is at 0 and the highest point is at 3. So for the range, we would want to say 0 is less than or equal to y, which is less than or equal to 3, and that's how we would define the ranges. We don't have to worry about what's in between them, we just need to know the starting point and the stopping point. Okay, and then when we get to 7, we have the function y equals 12x. It is an equation, it is y equals something, it's going to be a function. It represents the number of pages, y, of text a computer printer can print in x minutes. So if I'm going to identify the independent and dependent variables, and we've thrown out a lot of vocabulary here, you need to remember that there's several things that go together. Independent is the same thing as the domain, which is the x values. It's also the input. And then the domain, or the dependent variables, domain is the dependent, which is the range, which is the y values. So these are important. They all go together. So the independent variable in number 7 is the x. And the dependent variable is the y. And the good thing about algebra is, in general, nobody's trying to trick you by switching up x and y. In general, your y is going to be your dependent and your x is going to be independent. Now, in B, it says if your domain is 1, 2, 3, and 4, what is your range? So I'm going to answer this one by setting up an input-output table. So if my inputs are 1, 2, 3, and 4, what would I get out as an output to give myself my range? So I'm going to take my 1 and plug it in for the x in the equation. So I would do y equals 12 times 1. Well, 12 times 1 is 12. And then I'll replace that with a 2. 12 times 2 is 24. 12 times 3 is 36. And 12 times 4 is 48. So my range is 12, 24, 36, and 48. Range refers to your y values.